Halo Pak Yohan,
Halo Pak Vincent, maaf telat.
enggak apa-apa, belum mulai. Kemarin rame
Kemarin
punya Pak.
56 Pak.
Oh ya lumayan lah. Ya
Iya,
semoga hari ini juga segituan lah.
iya, semoga.
Ya nggak terlalu sepi karena kok ya pas kebetulan ini ya ada
Soft
banyak
opening.
acara ya, soft opening
Iya,
terus apa Pak Jimmy kedukaan, aduh.
iya, betul. Semoga banyak
Kapan
mahasiswa.
Pak Yohan mau ke Adijasa?
Saya mungkin nanti malam Pak.
Oh nanti malam.
Iya,
Oke. Nanti malam ada itu ya, ada ibadatnya nggak ya? Kayaknya ada ya Pak Yohan.
harusnya ada hiburan ya Pak ya. Ada ibadah penghiburan dulu.
Oke.
Iya, atau mungkin besok. Nah itu yang saya kurang tahu sih.
Hmm.
Selamat siang Pak Yohan. Ini sudah saya live
Hmm,
stream kan ya Pak?
Bu Sandra. Oh iya
Iya.
Bu.
Untuk hostnya saya serahkan ke Pak Vincentius atau ke Pak Yohan ini?
Ke Pak Vincent enggak apa-apa Bu. Saya
Langsung ya
bantu.
Pak ya?
Yes,
Baik.
iya.
Pak Yohan, ini kalau misalkan sudah ada satu peserta gitu, nanti dimasukkannya nanti atau sekarang gitu?
Nanti aja Pak, enggak apa-apa. Mungkin 5 menit
Oh,
sebelum acara gitu.
oke. Nanti ini mungkin saya jadikan Pak Yohan co-host kalian, boleh ya Pak? Siapa tahu nanti pas
Iya,
pas acara ada yang masuk-masuk bisa minta bantu untuk mengadmit gitu Pak.
iya, Pak. Jadi nanti
Ah,
Pak Vincent jadi saya fokus, ya saya bantu admin, terus saya bantu atur
iya.
spotlight-nya juga. Pak Vincent, ini saya lihat Rudi sudah datang, mau di-admit duluan kah?
Oh, boleh, boleh. Saya upload.
Boleh ya Pak ya? Jadi biar bisa ngobrol-ngobrol dulu.
Halo, Rudi.
Halo Pak, apa kabar?
Halo Rudi.
Ya, baik, baik, baik. Long time no see.
Mantap nasi. Baik, Pak. Iya. Sudah saya setting dulu background saya.
Oke.
Saya admit Prof. Anton ya Pak Vincent.
Oh iya.
Selamat siang Prof. Anton. Selamat siang Rudi. Terima kasih banyak Prof. Anton dan Rudi telah bersedia untuk join menjadi narasumber di acara Ubaya Global Webinar Series.
Halo, Prof. Ketemu lagi. Semoga
Ya,
masih ingat dengan saya ya, Prof ya.
sebentar saya ganti ini dulu. Ganti background, oke.
Ya.
Ya, baik.
Semoga masih ingat dengan saya dulu. Kita ketemu
Ya.
waktu kuliah tamu ya, Prof ya. Waktu dulu itu
Ya,
ya,
betul.
2022.
Iya,
Di sana
yang
jam
di
berapa ini, Prof?
mau jam 9.
Oh, masih pagi ya.
Ya.
Oke.
Ya, masih pagi, 9 pagi.
Permisi,
Oh, ini sudah ada
Ambil-
Pak Jok.
dicoba untuk share screen dulu, untuk memastikan nanti tidak ada masalah. Mungkin dari Prof. Anton dulu, mau share screen, coba share screen.
Ya, baik. Sebentar. Terlihat di sana?
Siap, terlihat Bapak. Dengan
Ya,
jelas.
baik.
Lalu mungkin Rudi. Oke. Terima kasih. Ini nanti dimulai jam 1 tepat kah, Bapak-Bapak sekalian?
Monggo, silahkan, Mbak.
Ya.
Saya ngikut saja.
Saya ikut siapa, Pak?
Kan jenengan yang yang menjadi tuan rumahnya.
Waduh, gitu ya. Ya, baik, nanti jam 1 dibuka, begitu ya, Bapak ya. Ini setelah ini kami admit semua dulu. Terima kasih.
Rudi, gimana kabar teman-temanmu yang lain? Seperti Abiza, Kristo yang di sana?
Ya,
Sudah balik ke Indonesia mereka?
Abizat balik ke Indonesia, Pak.
Oh,
Kalau Kristo masih di Brisbane. Ya,
oh, lanjut master atau?
iya. Kristo masalah baru lulus S2 kapan hari.
Oh, oke.
Terus Abizat habis S1 kerja di Jakarta.
Oke.
Iya.
Ini cuma kalian berdua ya, yang angkatan kalian ITDD yang
Iya.
apa masih di Aussie ya?
Iya, cuma saya Kristo sama Brian.
Brian. Nah, saya lupa Brian.
angkatan atas saya dia hitungannya.
Oh, saya kalau
16,
angkatan saya
iya.
sudah nggak tahu. Mulai angkatanmu saya mulai ngajar ITDD kan, angkatanmu ke bawah. Nah, mulai ngajar itu.
Iya, Pak. Masih ngajar ITDD, Pak, sekarang?
Masih sampai sekarang.
Iya. Mata
Sama
kuliah.
saya data structure, data science programming, terus apa ya, intelligent information retrieval.
Wah. Iya. Jadi masih areanya masih di data science sama AI gitu, Pak ya.
Iya, ya area itu aja. Di sana ini berarti selisih berapa jam ya, Rudi? 3 jam ya? Betul ya? 3 sampai 4 jam ya?
4 jam.
Oh,
Iya.
sudah sore ya di sana ya, berarti ya.
Jam 5, ya, benar.
Tapi di sana apa? Summer ya? Kayaknya di sana summer ya.
Sekarang barusan masuk autumn.
Oh, belum masuk autumn.
Iya.
Soalnya kan agak kebalik ya dari Eropa kan di Aussie.
Iya. Di sana Northern Hemisphere, di sini Southern Hemisphere.
Nah.
Ya.
Ya, di sini juga baru selesai apa namanya winter kan di Saudi, Arab Saudi.
Oh, baru selesai winter ya, Prof.
Iya.
Iya.
Di Saudi
Kalau
juga ada salju di bagian utara yang berbatasan dengan apa Jordan, karena Yordania kan sudah bersalju kalau winter.
Oh, oke.
4 musim ya berarti di Arab ya, Prof ya.
Iya, 4 musim. Jadi cuma kalau yang ada salju itu di utara, kalau yang di tengah sama selatan tidak. Yang di bagian utara yang berbatasan dengan Irak sama apa Yordania itu ada salju. Kalau di sini kalau di Riyadh juga 1 derajat cuma nggak ada salju. Kalau
Oh ya
musim
lumayan,
musim
1 derajat juga dingin juga.
iya, hanya kalau musim panas itu 50 derajat.
Waduh.
Panas.
Wah, itu iya ekstrim. Jadi perbedaannya itu sangat jauh.
Ini bagaimana Pak Yohan? Dimulai atau bagaimana? Saya kembalikan ke tuan rumahnya di sini.
Kalau Bu Sandra bagaimana?
Ini sih sudah ada 10 partisipan di waiting room. Mau langsung di-accept kah? Mau langsung dimulai saja dulu? Atau mau menunggu sampai jam 13.05, 2 menit lagi?
Bagaimana Prof. Anton? Mau dimulai sekarang kah? Atau bagaimana?
Ya, saya mengikuti aja. Ya, boleh jam 2 menit lagi boleh. 13.05 ya.
Ditunggu 2 menit lagi gitu ya Pak, berarti agar
Ya, betul.
banyak.
Ya.
Oh, tapi ini ada Pak Joko Siswantoro, saya admin dulu aja deh. Biar bisa ngobrol-ngobrol dengan Prof. Anton.
Iya. Betul. Nah.
Halo.
Halo Pak Joko, apa kabar?
Pak Joko.
Alhamdulillah baik.
Apa kabar Pak Joko?
Baik Pak.
Baik ya.
Minta backgroundnya di mana ini?
Ini dari panitia kan.
Saya nggak
Saya
dikasih.
kirim, Pak.
Oke, terima kasih.
Gimana sehat-sehat Pak?
Alhamdulillah.
Mudik nanti bulan Juni.
Oh
Saya
ya.
kan ketambahan ngajar di University Teknologi Brunei. Jadi kalau mudik saya ke Brunei juga.
Oh gitu.
Iya, di kontrak berapa 1,5 tahun. Ya.
Gimana Pak Yan?
Sudah saya send ke grup.
Oke ya, terima kasih. Rudi di mana ini?
Saya di Sydney, Pak, di Australia.
Oh,
Iya.
nggak pengen jadi dosen di Ubaya, Pak?
Ya, nanti saya kabari, Pak.
Oh iya,
Iya.
lagi nyari dosen ini.
Kamu harusnya langsung to the point saja, Rudi.
Iya,
Gajinya di Ubaya
oh,
berapa gitu? Gajinya di Ubaya berapa
hanya
gitu
Mak
loh.
Minsen itu berapa?
Tanya Pak Vincent.
Supaya bisa memperkirakan gaji di sana dan gaji di Indonesia itu berapa. Gitu.
Uni apa? UTS, bukan ya?
Saya di UNSW, Pak.
Oh,
Iya.
Yes, ya. Banyak teman-teman dari Indonesia ya di Sydney. Itu ada teman saya
Iya.
di UTS banyak.
iya,
Prof
Ya,
itu
banyak orang
Indra
Indonesia.
Mahia. Itu kan di situ juga ya, siapa
iya,
Anto ya?
di UTS ya, Pak.
Iya kan Pak, itu kan Prof Indra Mahlia.
Iya,
Ya, project. Di situ ada, oh iya yang betul, project terus apa lagi di Sydney. Ini di USIT juga ada. Yang baru pindah dari Amerika itu ini si apa Nelson Tansu. Itu ke mana? Adelaide kalau nggak salah.
Baik, karena sudah 13.07, saya izin admit partisipan. Siapa?
Ya, silakan Mbak.
Silakan Bu.
Okay. Hello, good afternoon, everyone. Thank you for joining the Ubaya Global Webinar Series 2023 in the event of celebrating Ubaya 55th anniversary. We gladly welcome for the speakers for taking your time here to share the insightful information, the faculty who support this webinar to be happen, and also the participants. Today, we are having the second sessions of webinar in Informatics Engineering, and in this special Saturday, we invite two distinguished speakers. The first one is Professor Anton Satria Prabuwono from King Abdul Aziz University, Saudi Arabia, who is going to present about the IoT services-based traffic congestion monitoring framework using the PEL model. Thank you for your time, Professor Anton. And we also have Rudy Ginardili, Ascom BIT MIT, from the University of New South Wales, Australia, as the second speaker, who will discuss about the data engineering, what is it, and why we need it. Thank you for coming to this webinar, Rudy. And within 2 hours ahead, the webinar will be moderated by Mr. Vincentius Riandaru Prasetyo, Ascom MCS. He's the lecturer in Informatics Engineering Ubaya, and he is the head of the Laboratorium Intelligence Systems. Without more ado, I'll give the floor to Mr. Vincent. Please, time's yours.
Okay, thank you very much. Good afternoon, ladies and gentlemen. Our first speaker today is Professor Anton Satrio Prabuwono. He is one of the professor of at Faculty of Computing and Information Technology, King Abdulaziz University, Saudi Arabia. He is also a visiting professor at the School of Computing and Informatics University Technology, Brunei. And then he has received his doctoral degree in industrial computing at University Kebangsaan Malaysia. Professor Anton also had experience in the industry as a technical manager at Coca-Cola Bottling Indonesia. And then he has also received the World Class Professor Award, Ministry of Education, Culture, Research and Technology Indonesia in 2018, 2019, 2021, and 2022. And there are many other experience and awards that I cannot mention one by one. Okay, now I would like to invite Professor Anton Good morning, Professor Anton.
Yes, good morning, Pak Vincent.
You
Yes.
again, how are you, Professor?
Okay. Yeah, fine. Yeah, and how about you?
Okay,
Yeah,
perfect,
hopefully everything is
Professor.
fine.
Yes,
all right.
Professor. Okay, today Professor Anton will present his topic with the title IoT Services-Based Traffic Congestion Monitoring Framework using BPEL model. So, Professor Anton, time is yours.
All right. Yeah. Thank you very much, Pak Prastyo, yeah, as a moderator. And first of all, I would like to thank you to the organizing committee for inviting me to deliver a speech in the event of Ubaya Global Seminar Series 2023, organized by Faculty of Engineering and Department of Informatics, Universitas Surabaya, Indonesia. All right, let me share my slide here. So can you see the slide right now?
Oh, perfect, Professor.
Vincent. All right. Okay. So today I'm going to deliver a talk, entitled IoT, Internet of Things Services-Based Traffic Congestion Monitoring Framework using business process execution language model. Case study in Riyadh City. So I'm Anton Satria Prabono. I'm with the Faculty of Computing and Information Technology in Arabic, in Department of Information Technology, King Abdulaziz University, Saudi Arabia. And then my collaborators are Haila Ghanim Al-Majad and Ari Bramantoro, from the College of Computer and Information Sciences, Al-Imam Muhammad Ibn Saud Islamic University, Saudi Arabia, and School of Computing and Informatics, University Technology, Brunei Darussalam. All right, so these are the content or the outline of my talk. As usual, the first I would like to introduce about the talk and mention about the problem background as well as the objective of the study. And then I would like to explain also about the traffic congestion monitoring framework, which is the content of the talk, and also the business process execution language model, that we use this tool, to develop the monitoring framework, and then the evaluation and conclusion. All right, so the introduction, as we know that the emergence of the traffic and will result to the traffic congestion, especially in urban road networks, and it is increasing worldwide, with the growing number of vehicles. Then, of course, it results in excess delays and reduce the safety, as reported by Kawaki 2017. And then, according to the survey by the High Commission for Development of Riyadh City, the population of Riyadh approximately almost 5 million citizen resident, and scoring their roads about approaching 1 million cars daily, with an average 1.6 cars per family. And then from these numbers of cars, 90% of them are private cars. It is reported by the Institute of Public Administration in 2015. So as you can see here, so 90% are private cars. And the traffic congestion is one of the main reasons for increasing the transportation cost to the extra fuel and wasted time, of course. And it is provided by the study Al-Sibai in 2011. Proved, he has proved that the cost of congestion create a heavy loss at that time, around 28 billion Saudi riyal. Right, so these are the typical congestion, in the big city, because of Riyadh is actually the capital city of Saudi Arabia. So we have two major cities here, Riyadh and Jeddah, with the similar traffic congestion like this. I think this is the typical in the big city, also happening in Surabaya, I think. Jakarta, of course, and also Surabaya. Right, so the rapid growth of the population has led to increasing the number of the vehicle annually. And in addition, it affected to the road maintenance and weather condition issues, as reported by IPA, Institute of Public Administration, in 2015. And the traffic department is responsible for accessing real-time traffic information through CCTV systems. However, the resident don't have any trusted service to access this information and detect the traffic congestion. I'm not sure why they don't trust for this kind of application. The reason why. And CCTV devices have some drawbacks, such as being affected by weather condition. As information here, we have extremely weather condition. During the winter, it approaching to 50 degrees Celsius, and winter 1 degrees Celsius, and during the summer 50 degrees, almost 50 degrees. So the gap is quite big between the summer and winter season here. Right, so since 2008, Riyadh municipality began to implement a smart street or smart city, especially on Prince Muhammad Ibn Abdulaziz Road, by providing a free wireless access to all residents. And then in 2013, Riyadh City is continuing its effort by launching smart roads and developed to combine the extension of the Oruba and Abu Bakar Al-Siddiq Street. And these are centrally operated by a control room in the, of course, in the downtown, close to those areas. So it aims to guarantee the premium safety standard for the resident by offering some services like a dynamic message sign, ventilation fans, and then also the emergency calling, surveillance cameras, and escape doors, especially between the tunnels, and also the alarm, bells and alarm. If there is an emergency happening, then they will trigger or initiate to switch on the alarm. And according to Koduri et al. In 2014, they developed a traffic information interface based on historical traffic data. So this project was aimed to show the drivers an output in the public map as image processing of the traffic speed details, as well as the speed limit. And then study done by Wang et al. In 2011 proposed a vehicle cloud computing architecture based on 3 IoT layers, Internet of Things layers, which is a device layer, communication layer, and service layer. And by using a cloud computing technique, 3 layers enable devices, network, and services exchange the information with each other in real time. And then the other related works have been done by Kawaki in 2017. He designed a geodatabase that includes the road network with a direction located in Jeddah city here, and several GIS functions used, including the network analysis and overlay analysis by using ArcGIS 10.2 at the time. And then the result of this research were utilized in evaluating congestion point, yeah, according to road direction. Yeah, then it then help the planner to reassign. Yeah, it's actually even for the police department, yeah, to reassign the road direction to mitigate the congestion point. And then, as mentioned by Tahir Keli et al., the smart cities network have been designed to handle diverse field of life, including the transportation, electricity, healthcare, banking, and as well as the administration sector. Yeah, and there are various types of the smart system have been implemented in smart cities, such as IoT, smart grid, wireless sensor networks, and intelligent transportation system, as reported by I et al. In 2018. So this is the significance of this study. It is observed that almost all the previous researchers, studies that talk about IoT frameworks and focus only on 3 or more essential layers. However, each researcher names the layer differently. That is why, I mean, in this case, there is no standard for the layer that are developed by all these researchers. And today, the integration layer can be used for integrating the service of IoT, and it is not available yet. And by using the BPEL tool, we can actually integrate several existing and new services with each other by defining a business, especially this part, business workflow for each services in one, for each service in one BPEL model, business process execution language. So the objective of this research is to provide the framework of traffic congestion monitoring via numerous IoT services to a resident of the city at any time and anywhere on the roads. And the details of the objective, we can say the first one is to present traffic congestion conceptual framework. So the framework here for Riyadh Smart City, to provide the resident with the effective services, and then to compose the new services from existing services to support the traffic congestion framework by utilizing the BVEL tool to be more interactive for the residents on the road. And then the third one is to integrate the multiple services and enable the resident to choose the preferred service by using BPEL model. And so these are the traffic congestion monitoring framework. The proposed traffic congestion monitoring framework contains a fixed and mobile platform, including the support of sensors, mounted on the vehicle, and the sensors will collect the data and transfers to the cloud via the internet, and will offer the new services to residents. So the conceptual framework is shown in this figure. You can see here. So the first one is actually the physical layer. The first layer, with the RFID and CCTV. And the second layer, for the framework is the communication layer. So it provides the Wi-Fi, 4G, 5G. For nowadays we have 5G, and LTE and WiMAX. And this is actually the rule of this the integration. I mean BPEL, integration layer. The role of the BPEL is actually as the integration layer here. So we'll integrate, will be interfacing between the communication layer and application layer with the business process execution language. And the fourth layer is the application layer. Will provide the vehicle counting service, video streaming service, Yeah, so these are the services provided by actually the integration, the BPL here, yeah, integration. Yeah. Vehicle counting service, video streaming service, dynamic message sign service, and alternative rerouting service. And this is the traffic congestion monitoring architecture. Yeah, actually the same as the previous figures. Yeah, yeah, only with the architecture base. Yeah, for this figure. Yeah, so physical layer, the first layer, second layer is communication layer. So the third layer is here, PPEL, and the application layer also mentioned previously here. Yeah, so then this application can be accessed by the mobile devices or even web services. Also by fixed and mobile application. So in physical layer, so they install, yeah, we need to install the CCTV and also the RFID reader, yeah. And then we'll connect to the internet and will be supported by the cloud computing service. So this is the integration layer, which is the BPL model play the important roles. Yeah, and then the business process is actually, PPL model is actually a language used to define how the business process involving web services and combine and execute both in a smooth manner. So these are the notation, yeah, represented by the BPEL with the notation and definition. So you can see the first one is request or invoke, yeah. So it will ask the operation and receive notation, yeah, we'll get an incoming request data and replay, yeah, replay request, yeah, to external source, and assign notation will copy the data from one place to another, if sequence, flow, and so on. So these are the PPL notation for the framework. Yeah, and integration layer, yeah, for PPL, the goals of the using PPL models in the framework are to define the business processes. So then we have to understand the business processes for the traffic congestion monitoring framework by using the extensible markup language and XML, or XML. And the PPL layer clearly represent the flow of each service, such as the, as mentioned before, yeah, vehicle counting service, CCTV live streaming service, rerouting service, and dynamic message sign service. Yeah, and it will be provided in graphical representation. And BPL has multiple graphical notation to show how the business process works and allow the use to blend it, to be blended as seamlessly as possible, yeah, for the combining multiple service to be one service. And BPL is able to combine the multiple services, yeah, combining RFID services, as we can see from the architecture, because of from the physical layer, yeah, up to, yeah, until to the application layer. So it will be combined by the PPL and integrated to be a one service. And the developers can, yeah, easily develop application and services by using this model, yeah, using, of course, the XML code, yeah, to create the database modeling. And these are the application layer, yeah, provided by the PPL, yeah. And we develop the framework, and we can provide these services, yeah. The vehicle counting service, vehicle counting web-based application, yeah, and then the CCTV live streaming service, dynamic message sign service, alternative rerouting service, and these are the module, the integration module, which is traffic congestion monitoring service, yeah. And then we can see by one by one for each application, yeah, by using the PPL model. And the first one is the vehicle counting service. So vehicle counting service is to display the exact number of the vehicle in a specific street. Yeah, so only the specific street for one lane. Yeah, one lane. It depends on the number of the RFID reader actually. How many, and also the camera CCTV, how many they install on the road. So then we can monitor the specific street, for even for all lanes provided. So it also displays the average number of vehicles, for a specific period of time, because of usually the congestion, happens during the we can say walking hours, working days, and in the morning usually, and also evening during the the end of the service or the work day. We can say that is the peak season, and we can see here vehicle counting service, the model VPL model, from the beginning, main receive the vehicle, will receive the vehicle counting service request, and will invoke, or request the vehicle counting service, and it will cover 2 specific roads only in this framework, because so this is just for the study. So we cover Northern Ring Road with the RFID reader and King Fahd Road. So then they install these devices to both roads here. With RFID tag 1, tag 2, tag 3, tag 4, and so on. It depends on how many numbers of RFID installed on the road. And then assign all data to Northern Ring Road, RFID reader, and also data to King Fahd Road here. And it will invoke or request the internet service, because so it needs to be connected with the internet service in order to send the data to the cloud computing or cloud service. And then how it connect to the user or the resident here. So the assign data to cloud storage, and citizen or resident request the internet service. And then we'll receive the values from the cloud storage. Here. So this is actually the communication between the user, and also the system, by using the cloud storage. And then request the Google Maps API service and assign number of vehicles to the map, and will reply the number of vehicle to the users, or to the residents, on the map. So these are the vehicle counting service PPL model. And then the output, as we can see here, vehicle counting web-based application. So the service output will result here, will show the RFID reader, number 5 in this case, and the road, cover the Northern Ring Road, road lanes 5, road lanes 5 only. So because usually we have 5 lanes, for one direction, and so for 2 direction it will be 10 lanes, and number of vehicle 10 at that time, and number of vehicle per lanes only 2, and number of vehicle per 20 minutes equal to less than 1, or 0.7 we can say. So then we can see also the time exactly here, what time and the date, and this is the setting for vehicle counting web-based application. So in this case, we take from King Fahd Road. For example, we have 2 roads for this study. And then we put some parameters here with the RFID readers as well. And then the vehicle traffic. So we select set the vehicle tag, for example, and RFID reader, and after that we will monitor the congestion traffic of this specified road. For example, here Northern Ring Road, and follow the King Abdullah Road, King Fahd Road, And then the next service is CCTV live streaming. So by using this PPL model, we can provide CCTV live streaming. CCTV cameras are installed along the Riyadh Road, and connected to the internet to store the received video in the cloud storage. And then at the same time, the data are streamed from the cloud to residents. So means that the residents can access this live streaming data from the cloud. And then the resident or the users can view the live streaming video to the specific road. So for example, they want to go to the downtown or business center district. So then they just find appropriate road in order to reach the destination in the certain time, for example. So if the user want to reach the destination 10 minutes, then they can find appropriate route in order to reach the destination. Right, so this is the live streaming, CCTV live streaming service by using the BPL model. From the main, then we'll receive the CCTV live streaming service request. And the request CCTV or invoke the CCTV live streaming service. So it consists of two parts. Because we cover two roads here, two areas. The first one from Northern Ring Road and the second one from King Fahd Road. So then if we cover 5 roads, then we just add some additional road here with the same type or the same services as provided here. And then from here, the citizen can access the internet service and will receive invoke or request the videos and will receive the video from cloud actually, then will request the Google Map service, and the user choose the location because of there is two locations here. The first one is Northern Ring Road, and the second one is the King Fahd Road. So then only the the coverage area only 2 so far. So then we can actually expand to some numbers of the areas. And then assign the video to the map. And reply the video live streams to the users or the residents. So this is the CCTV live streaming service output, as you can see here. So even we can see a small window here for the real-time video in the certain road that requested by the user. So then we can see here, click this area and will appear the small window of the real-time condition situation in this road according to this map of course. So then the user can just click which area that they want to see, and then will appear this icon and will appear the real-time or CCTV live streaming output on the application. And then the third service about the dynamic message signs, DMS, it also provided by the PPL model. So propose to connect the DMS to the internet, and dynamic message board is able to provide the real-time messages to residents. So then it will appear the real-time messages like this on the certain road. So then we can see the model here for the DMS service, PPL, the main, and also request receive the dynamic DMS and invoke the DMS. And yeah, because we have a two coverage area, two coverage road here, northern and also the Kingfat road. And then it follows the next step, by request by the user, of course, and we'll select which area that want to see, the dynamic message sign. Right, and this is the output in mobile application for the dynamic message sign service. So then we can see this is the dynamic message signs. Okay, for example, the information here, traffic congestion at 700 meters. So it shows about 700 meters. Maybe after this road, traffic congestion. For almost 700 meters here. So then we can just click which area that we want to know about the situation or the condition. Then it will appear, the small window here, the information of the traffic congestion in the specific area. And then the fourth service is the alternative rerouting service. So it is an alternative rerouting service if there is a, so provided here, alternative rerouting service will be provided if there is a traffic congestion on some roads, and the service will give the user an alternative road based on the real-time information. So then this is the PPL model for the alternative rerouting service. So from the receive the alternative rerouting service request, and will invoke this information and will divide into some RFID readers. So we put on the two roads, but then there is many RFID readers, for each road, so not only one. I think there is a 4 or 5. So then we can select which area that we want to see, for the condition and situation. If there is the congestion traffic happening in this area, then it will provide the alternative rerouting service by this model. All right, so then this is the output, the output of rerouting service that we can see from the application. So for example, in this area, with this RFID sensor, and with 55 cars and 85 cars, 110 cars, 85. So then we can select which area that we want to follow from this road. So we want to avoid this congestion, and we just find the alternative rerouting service, or alternative rerouting road here. So this is the integration actually. So from these 4 application or services, we can integrate by using the PL model also here. So integration services. So these are the main objective of this PPL model. So we integrate all the services, becoming a single service here with the PL model. So the traffic congestion service combines the vehicle counting service, CCTV live streaming service, DMS service, and rerouting service in one model. So this is the traffic congestion service output, the integration model, for mobile application. So then we can see the rerouting, DMS, live streaming, video, all these services we can see from the one and from the single application. And then these are the evaluation have been done. So then we just conduct the surveys, finish the survey conducted on the several users. So because of this application is actually the framework only. I mean, we provide the, like the idea, to develop the smart city, and we distributed the evaluation for the certain potential users. So then we got this result, and then by using the software as a service, this BPEL model is actually the appropriate approach, to develop the framework, to enhance the public service, because we can combine and integrate all the services to be one application, which is very easy to be accessed by the resident or the users. And we will provide the transparent information to the public here. And then with the software as a service approach is actually advanced in the framework, a framework development through this model, BPEL models, which are useful for business managers and developers, not only for this IoT application, but also for some other areas, like a business, and for the decision makers as well. These tools can be used or can be utilized by the managers, directors, and so on. All right, so that's all my talk today, and thank you very much for your kind attention, and we'll give back the time to Pak Vincent, the moderator. Thank you very much.
Okay, thank you very much, Professor Anton, for giving us an interesting presentation. Okay, ladies and gentlemen, now come to the question answer session. We have 10 minutes for question answer session. For all participants, if you have any question, please raise your hand. Okay, I have one question from Mr. Joko Siswantoro. Mr. Joko Siswantoro, please.
Okay, thank you, Pak Vincent. Nice presentation, Prof. Anton. I would like to ask about the number of services that can be combined using BPEL framework. So is there any maximum services that can be combined? And the second, if the number of services that increase the combined in by using BPEL increase it, is there any time delay to the user to get all information? And the third, for the counting vehicle services, in the proposed system, you are using RFID reader. So meaning that every vehicle in the Riyadh city need to be using RFID. Okay, thank you.
All right, thank you very much, Joko Siswantoro, Dr. Joko. Yeah, very good question. About the capacity, or the capability of BPEL model. So should I respond this question directly? Immediately, Pak Vincent. Can
Yes,
I
please,
respond?
Professor.
Yeah. Okay. All right. Okay. The first one, it is not mentioned in the in the technical specification of BPEL, about the maximum number of the service that can be integrated or combined. But I guess, of course, there is a limit. But in this case, we just try only 4 services to be integrated. So that information actually is not available. On this specification, technical specification of BPEL. So then you can just try how many services that you want to be integrated. Then after that, see the response of the system or the the performance. I guess also there will be a delay time. If you have many services to be combined, right? So for example, 30 services, or let's say more than 10 services. Because this is the nature of the system. When we increase the number of services, then it will be more complex. For the system development and more complicated. Then yeah, of course, the process time processing, it will take more time, yeah, for the processing, and yeah, it will affect to the time duration, yeah, when give the response or feedback to the users. Yeah, and then about the RFID, yeah, you are right. Yeah, based on this proposed framework, actually we need to install the RFID, but then some cars in Saudi Arabia, they provided the RFID. Yeah, I mean installed by the was it? I'm not sure whether the distributor here or the companies, but some cars they have RFID and also Bluetooth. Yeah, but unfortunately, the Bluetooth, the distance of the range of the Bluetooth is, I think, less than 10 meters. But with RFID, yeah, with the, we can say high power, yeah, because of high power RFID, we can use even more than 10 meters, 50 meters sometimes, or even 100 meters, yeah, the distance. So that is the thing. So we have this technology because of some, companies, yeah, for the car companies or manufacturers, car manufacturers, automotive manufacturers, they assemble RFID, yeah, on the car, yeah, like Wi-Fi. Wi-Fi also they have, yeah. Some cars they provided the Wi-Fi device, yeah, on the vehicle. So then we don't need to install by ourselves. Yeah, that is the thing here. That's why we use RFID. Yeah, but then maybe very limited, yeah, very limited brand, yeah, in this case. Yeah, so then we can combine with the others devices if we want, yeah, with the common one, or we just check the availability of the devices installed on the car, yeah, especially in Indonesia, yeah, because I'm not sure whether in Indonesia there is a car with the RFID or Bluetooth assembled by the manufacturer. Yeah, if available, then that is good. Yeah, so then we can provide this model also for Indonesia. Yeah, that is my answer, Pak Joko.
Okay, Prof. Anton,
Thank
thank you
you.
very much. Is it possible to
Welcome.
replace RFID model by using a camera to count the number of vehicle and then
Yeah,
connect
yeah.
to BPIL?
Yes, yeah. In this case, we use two two devices here: camera, yeah, CCTV camera, and also RFID. So then you can also use the other tools or devices, yeah, in order to detect the car movement, yeah, in this model.
Okay, thank you.
You're welcome.
Okay, thank you, Professor Anton, for the answer. Okay, maybe another question from participants. Okay, I think I have one question, Professor Anton. What is your reason for using the BPEL model compared to other model? For example, compare with WLI, yeah, or web logic integration. Why use BPEL model to this technology?
Guys, thank you very much, Vincent. Okay, good question. So this model is actually relatively easy to understand, yeah, when we develop this framework, yeah, especially for the integration, because so this is actually the model that used by business process, yeah, I mean the decision makers, yeah, when they provide the the comprehensive report and they want to integrate, yeah, some kind of services to be one service. So that is the thing. So in this case, we found that PPL are more appropriate and suitable for the traffic congestion monitoring framework. That is the thing. Then I guess it is easily to deploy, yeah, especially for the user, because of the application. One of the objective of this development is user-friendly application. So that is when we develop this integration, yeah. So we can easily deploy this application, yeah, to the simulation part, yeah, or simulation step. That is why I guess we can easily also deploy this to the users, and user can easily use or occupy, yeah, or utilize this application. Thank you, Pak Vincent. Yeah.
Okay, thank you very much, Professor Anton. Okay, to limit the time for our schedule, so I will end the first presentation by Professor Anton here. Once again, thank you, Professor, presentation. We hope we can meet or collaborate again in the future, either offline or online. And then finally, give the virtual applause for Professor Anton. Thank you very much, Professor Anton. Stay healthy.
Thank you very much.
See you.
Yeah, thank you. See you next time.
Okay, ladies and gentlemen, we will start with the speaker. Our second speaker today is Mr. Rudy Ginardi Lee, Sarjana Komputer, Bachelor of Information Technology, Master of Information Technology. Okay, and then I will briefly read the Mr. Rudy CV. Wait a second. Okay. Now, Mr. Rudy is a casual academic at University of New South Wales, Australia, and then he is also a data engineer at Regic, Sydney, Australia, and then he has received a double bachelor degree in information technology at University Surabaya and the Queensland University of Technology, Australia. And he also received a master degree in data science and engineering at the University of New South Wales, Australia. Okay, now I would like to invite Mr. Rudy. Good afternoon, Rudy.
Good afternoon. Thank you.
Are you ready? Are you ready for your presentation?
Yes, ready.
Okay. Today, Mr. Rudy will present his topic, data engineering. What is it and why we need it? So, Mr. Rudy, time is yours.
Right. Thank you, Pak Vincent and the organizing committee. Hello, everyone. My name is Rudy. Very honored to be here. And I'd like to share a little bit about what is data engineering and why we need data engineering. All right, so before we start, can I confirm that I'm sharing my screen?
That's perfect.
Yeah, thank you. All right, so just a little bit about me. Thank you, Pak Vincent. I'm an alumnus of this university, so it's always good to be back here. And then I went to Australia and did my master's degree at UNSW. I started my career at the same university as well, and I've been teaching since. And I'm also a data engineer at Regic, perhaps the most important portfolio of me for today's talk. And let me start by saying this important quote. Some of you might have heard this. It's a very popular quote, data is the new oil. This is a term that was coined by a British mathematician. And this is to highlight the importance of data nowadays. So it has been comparing data to the importance of oil worldwide. And seeing from this statistic, the worldwide data consumption, we can see why this term was coined, right? So as we can see, for the past decade, our worldwide data consumption on internet has growing so rapidly. So there must be importance in how to use this data, and this is a very, very important tool in any organization, right? So of course, this is an estimation. So in 2023, we are expected to reach about 120 trillion gigabytes. I think that's correct. 1 zettabyte, 1 trillion gigabytes. So this is why we need data engineering. So this is one of the driving force why more and more organization, especially a big organization, requires a data engineer in their team. So before I go through what is the data engineer and why we need it, let's take one simple example. So suppose we have this organization and we have a marketing analyst team, right? So they like to analyze what is the sentiment of their marketing, how efficient their marketings are, and what is the impact of their marketing, right? So this is it's quite a big organization, and have been marketing a product in multiple platforms. So it's very common nowadays to see Google ads. So you got data coming in from Google Analytics on how well your marketing is going. You got your own website, and you can analyze what the traffic of that website is, where people come from. And then you got various advertisement firms. And then, of course, the social media marketing, right? And of course, to track this incoming sales and the marketing fees, you got a bunch of invoices coming to your desk. So this is a problem for the marketing analyst. Why? Because this so many data sources, they are not structured in the same way. So if you pull some data from Google Analytics, and if you pull data, say for example, Facebook, they might be in different shape, right? So they might be the same table, but two tables might contain different fields. And that's not to mention the data type that's coming in can be also different. Not to mention we have PDF, we have CSV coming in, we also have image coming in that we need to structure and analyze. So here's one of the possible setup. It used to be quite popular setup. Is that we assign one person or one team that is very good at spreadsheet, at Excel or Google Sheet, right? And then this person or this team's job is to take this data source and compile that into a more readable format by the marketing analyst, right? So they're quite important people in the team, because without them, we cannot use this data source. We cannot structure it in the way that's readable. And also, not to mention that some of the data sources that are coming, some of them may contain outliers, some of them may contain inaccurate data. If you receive a CSV file, some of the rows might be broken, image might be corrupt. So there's a lot of things that needs to be considered by this middleman, right? So, but there's a problem, right, with this setup, right? In the short run, this is good. But then the data starts coming in, more and more data source starts to be joined together. And then the amount of data that's flowing in starts to get larger and larger, right? And then it starts to become unfeasible. Why? Because more data, because this is such a manual work. We use Excel, but it's a lot of labor work, manual work, and it's getting not sustainable because data gets bigger and bigger. and either the organization getting more and more people working in the spreadsheet, or the spreadsheet master gets burned out, right? Not to mention Excel, the spreadsheet application, they actually have a limitation on the amount of data that they can process, right? So what is the solution, right? Okay, so another solution, another possible solution, maybe we can automate things. Maybe we can automate the stuff between the data source and our analysts. And then we ask the software engineer, okay, so it's a software engineer, let's come and build a script, right? Build a script that can read from these data sources. We define what is the accurate data. We define what is outliers. We can remove that using our script, and then put that in such format, maybe a table or CSV, and we hand it over to marketing analysts, right? So they would develop something called ETL pipeline, right? So ETL stands for extract, transform, and load. So we are extracting the data from the various data sources. So this pipeline can imagine if it's an oil refinery, right? This is the pipeline. So we get the oil from crude oil, right? And then we process that. So it means, so that's the transformation process. So the data that's dirty, we clean it out, and then we load that and we transfer that to the team that needs it. But then that's the setup on demand, right? So if you look at the previous setup, this is when the marketing analyst, needs it, then we run the pipeline. So we want something that's not just on demand, right? As the data grows, we might want to process this data bit by bit, right? So we keep the pipeline running, but then as the marketing analyst doesn't always pull the same data over and over again, once that data being processed, then we can store it into some data storage, right? So there's another terminology. So we got a data warehouse, right? So the data journey comes from the data source, getting in the data pipeline, and then it gets stored in data warehouse, right? So this might be some new terminologies for some of you. What is data warehouse, right? So data warehouse is a type of storage, right? What's being stored inside data warehouse is already a structured and normalized data, right? So it's already a complete detailed data. That means this data, ideally, when the other team is working on that data, or say you can imagine the marketing people, if they pull the data from the data warehouse, they can be sure, all right, this data is accurate, right? So it's data engineer's responsibility that the data that's being pulled from the source and then being put into data warehouse can be the central version of the truth. Okay, so it may sound simple. You just get the data, transform, and store, right? But here's another caveat, right? So because the scale of the data is so large, we have to make sure this warehouse is optimized, right? So it's definitely have to be catered for very fast queries. So we got other teams that keep constantly pulling data from the warehouse, and they want the query that runs in reasonable time. So imagine you have a web application, and then you're pulling data from the server, so from this warehouse, and it takes ages to load. So you don't want that, right? So if you imagine you're accessing YouTube, and how they get the data so quickly is because the data throughput has been optimized, has been maximized, right? So if you put that into analogy, self-analogy, data warehouse is like a warehouse, right? So the items that's being put into that place, they are already properly labeled. They're properly stored in specific way. They're already labeled in such a specific format, specific way. So when you go to the warehouse, you like to collect certain items, you can get it fairly quickly, for a reasonable time, right? And the design of that warehouse can determine whether you can get it quickly or not. Right? So it's the same thing as our data warehouse, right? So how we design it can affect the running time of data pulling and push. Right? So one way to do it is indexing these data points that's been stored in. So indexing is, if you put that into analogy, into warehouse analogy, indexing is the same metaphor as saying that the data is labeled, right? So the data that's being stored, they have their own certain key, they have their own certain index to ensure the data throughput, the query is really, really fast. Right? So in a nutshell, so this is data engineering in a nutshell, pretty simple, just a few words. So our job is to prepare the data for analytical or operational uses for the other team. So that's why if you look at the previous diagram, actually a lot of data engineers have a lot of software engineering background. Some might say data engineers is software engineers who are specialized in data, or they have good knowledge of data. And in some way, it's kind of correct as well. But as data getting bigger and bigger, again, the scale is becoming more and more specialized field. So again, let's circle back to the data itself. So why the data needs our processing? Why do we need to be processed by the data engineer, specifically by the data engineer? So the data might be in complex format. This is one thing, or rather in real implementation, especially in large organization, the data always be in a complex format. So what do I mean by complex format? The data can come in such many structures, right? Some can come in image that is represented in basic 64 string. Some might come in a video that is represented by the other thing, right? Some might come in very simple things. It can come in CSV format. It can come in spreadsheet. That adds up a lot of complexity, right? So that's why we need data engineer to specialize in processing these formats, right? And then we need to ensure that the data is fully clean and format, right? So if the data itself is not clean, it's not accurate, then the other team cannot use it. So the essence of data engineer is also to ensure that the data that's been stored within your organization that's already accurate. So it can serve as the version of truth for the team, right? And then that's the main objective. Now the challenge is that how can we ensure that this data, when they are processed in such an optimal way, right? So when we read it and you pull it by other team, it has very, very high performance. You can run a quick query through it. And again, I say this a lot, but this is the essence of data engineering. The main challenge in data engineering is the data scale. So the task is simple, but the challenge is you have a lot of data that needs to be processed and needs to be processed in reasonable time. And this is to give some examples on how data engineers work with other roles. So data engineers is usually the middleman in the process, and it needs to work well with other roles as well. So it can varies a lot between different roles, but let me give two examples, perhaps the most common examples. So the first one, data engineer and analyst, can be marketing analyst, sales analyst, operational analyst, right? So analysts, their job is to find patterns, and then from that pattern, they would communicate results and they make business recommendations. And then they also maintain detailed knowledge. Right? This is why the data engineering is very important, right? Because we are making business recommendation, and it is very important that the data that was used to make that recommendation is actually accurate, right? It's not skewed, it's not biased. It's not. If there's any bias, then it should be noted. If certain inaccuracy, it should be removed. Right? And analysts, they often work with big scale data to present that result. So of course, they need to pull the data in optimized way. So you don't want the analyst to take days to import the data from the warehouse. You don't want that. And that's with analysts. With data scientists, so perhaps a little bit difference between data engineer and data scientist. It's a common topic, right? Data engineer versus data scientist. So they often work together. In fact, in many organizations, it is set up that data engineers and data scientists work hand in hand. So data scientists, they usually work on AI algorithms, and they would do predictive analysis. Of course, that's not all they do, but for this example, this is the kind of data and scientists that we are looking for, right? So they rely heavily on structured data. So the machine learning model that's being built, the predictive models that are being built, they rely on very specific data structure. Right? It's very specific format, very specific feature that's been pushed in. Right? So, of course, to train this model, it's often that data scientists need to pull the large-scale data, right? So it's also important to train these models. The loading speed of the data is reasonable, right? In reasonable speed, so that it doesn't bottleneck the model training. So that's perhaps two common examples of the relationship between data engineer and the other roles. So I have talked about how you can what is data engineering in a nutshell is, why is that important. Now, to become a data engineer, what do I need, right? What are the tools and skills that you need, right? So the first thing is very important. It's definitely the good understanding of data. What are the best practices of data? What are the definition of the outlier? So of course, if you're working in some organization, it's also good to have some domain knowledge about the data that's being consumed, that's being pulled into that organization, right? And also, it's good to know what sort of query that the other team needs, right? The more common queries, of course, they need to be optimized. The less common queries, they can be paid less attention to. All right. So in terms of optimization, in our previous discussion, we talked about optimization in the data warehouse and data pulling and reading. And of course, it's definitely very important to know good knowledge about data structure and algorithms, because this is how we can know how to optimize the data throughput. And then cloud computing is getting more and more important. So it is very unlikely that we can process such large-scale data and then store that into our local machine. It's almost impossible. Right? So, and also it's very, very expensive to create an infrastructure that can hold such large-scale data. We are talking about in some organization, maybe a mid-level organization, we're talking about terabytes of data that's being processed every day. So it is very expensive. And what's the most common thing that people would do in organizations? Use cloud computing, right? Cloud computing is more financially feasible, and of course, it also can provide more computing power than the traditional setup. And two of the most common cloud computing, of course, it's not only limited to these two, but these two are quite common, are Amazon Web Services and a Google Cloud Platform. So good, because we are hosting our data in cloud, and we're processing our data in the cloud most of the time as well. For data engineers, having that good knowledge of cloud computing is important. And what are the programming languages that I need? So to script the application, the most common language is Python. Perhaps some Java is also quite important, but Python is definitely the leading programming language for most of data engineers. And of course, to know what queries that are being used by other team is very important that you understand what is SQL itself. And that's also true for the database tools that are being used, right? So the two most common, perhaps, setup of database is the SQL or NoSQL databases, right? SQL can be MySQL, Postgres, and also you need to think about how to design the database. What are the tables? Let's say we take examples for SQL databases. We need to know what are the tables that we need to store, and in each table, what kind of field that we need to store, which field can be derived from the other field, which in these derived fields, is it important that we generate it every time? What would be the computing power would look like? And it's also important to discard some the unimportant information. Is also important to identify which are the important information that we should store in our data warehouse. So these are the first 6 things is the hard skills. Perhaps most software engineer will have some of these skills as well. So that's the hard skill. And now the soft skill. So perhaps this is incredibly important, and you need to pay a lot of attention to it if you want to be a data engineer. Is the ability about to think about scalability. And again, scale. Right? So this means always think about, if I build this pipeline today, would this same pipeline work for the next year, right? Because as we can see, the data consumption of the internet every year is rapidly growing. Right? So it's important to think about when you build something, it's important that if the data scale goes up, then is it possible for us to modify this pipeline to cater that requirement? Right? So always think ahead, and that's very, very important to become a data engineer. I think that's all for the talk. Thank you everyone for the kind attention. I'll give back to the moderator.
Okay, thank you very much, Mr. Rudy, for giving us an interesting presentation. Okay, ladies and gentlemen, now come to the question answer session. We have 10 minutes for question answer session. If you have any question, please you can raise your hand. Any question for from participants? Okay, Mr. Joko, please.
Okay, thank you, Pak Vincent. Mr. Rudy, as data engineer, because data is very related to statistical method, yeah. For example, for cleaning or for processing data. So, is a data engineer need a statistics background or mathematical background for become a data engineer? And as your experience, what kind of statistics background or mathematical background that needed by a data engineer?
Thank you. Yeah, so for the mathematical background, it is quite important for data engineers. Although compared to data scientists, mathematical background is less emphasized in data engineering. So in terms of relations, if you look at the software engineers and data scientists, data engineers is closer to software engineering. But of course, it's important for us to identify, especially in data, how to identify what are the definitions of an outlier, for example. It also depends on the industry as well. So if it's very heavy towards the AI, then we need to consider some correlation between the data and what we can generate from that data if we were the data scientists. So in our field, the mathematical background is important, not in the statistical analysis itself. So it's more towards the data scientist field. Our mathematical background is important in optimizing the data pipeline run. So one of the most important knowledge perhaps is the discrete mathematics in the optimizing it, because it allows us to think what are the possible ways, and also it's important for us to analyze what are the time complexity of certain runs, and what are the possible algorithms that we can implement to further optimize the run.
Okay, thank you, Mr. Rudy.
Okay, thank you, Mr. Joko, for the question, and thank you, Mr. Rudy, for the answer. Maybe any question for from participants? Okay, I have two questions. Yeah, for you, Rudy. So if we don't master, if we don't master in the Python programming language, is it still possible for us to become a data engineer? Because there are many, I think, because there are many less programming tools that we can use. For example, RapidMiner, KNIME, or using cloud computing technology like AWS, and what do you think about that? And then my second question, I'm also interested in data warehouse. In your opinion, is it better for us to build a physical data warehouse, or is it better to use cloud technology, and why?
Thank you for the question. For the first question, is Python important? So the short answer for that is yes, because the demand for the current market in data engineering is the ability to work in Python. But in terms of mastering Python, is actually not very difficult if you have very good fundamental knowledge on the other programming language. In data engineering, Python is just a way to express our logics. So there's also importance in Python in a way that we use the infrastructure as well. For example, in AWS, there's a lot of components that we can spin up using Python. So if you heard about AWS Lambda, so it's one of the most common service in AWS. Is the usage of that we can use Python to use it. And also Python is especially important in data engineering because there are a lot of packages, there are a lot of libraries that are specially catered for data processing and cleaning. So that's why having knowledge about Python, although it's not limited to Python. So if you don't know about Python, it shouldn't be a main issue for you to not become a data engineer. But not in that regard. There's a lot of the current tools that are built on Python. So that's why Python is important. Yeah. Okay. Does it answer the first question?
Okay, for the second question.
Yeah. So for the second question, sorry, would you mind repeating the second question again?
Okay. About data warehouse, about data warehouse. It is better for us to build a physical data warehouse, or it is better to use cloud technology, and why?
Yeah. So for the current trend, it is very common for a lot of companies or a lot of organizations to use cloud computing. So all data, the processing, the storage, they are all hosted inside a cloud. And there's very important reason why. Because creating a physical data warehouse, that is very expensive. And most companies in the world, they don't have that financial capabilities to create such optimized infrastructure. And also maintaining that infrastructure can be quite costly, and it's not very economically feasible. So that's the main reason. So that's why in terms of the usage, local infrastructure versus cloud computing is preferable for most organizations. Yeah.
Okay, thank you very much, Rudy, for the answer. Okay, maybe another question from participants. There is no question. Okay, if there is no question, so I will end for the second speaker now. Once again, thank you very much, Rudy, for giving us an interesting presentation. Yeah, we hope we can meet or collaborate again in the future. So, but for especially for Department of Informatics Engineering, we hope you someday when you come back to Indonesia, we hope you can join with us as lecturer in our department in informatics engineering, Rudy, Okay. Okay, finally, give the virtual applause for Rudy. Yeah, thank you so much, Rudy.
Thank you, everyone.
And see you next time. Okay, ladies and gentlemen, we finally come to the end of this seminar. Before I close the seminar, I would like to say thank you very much to all the participants today. I also apologize if there were any mistake while I was moderating this seminar. That's all for this seminar, and see you again in another seminar. Okay, I go back to Mr. Johan or Mrs. Sandra, I think.
I think we can return it to Miss Sandra.
Okay. Thank you very much for these interesting topics that we have discussed today. So by this, we are going to end the room. Thank you so much for taking your time. Have a great weekend ahead. Goodbye.
Thank you, terima kasih semua.